Hi, I'm Louise, and in this video I'll explain some of the issues that your business might encounter if you want to connect renewables, such as solar panels, to the electricity grid. Most businesses take their electrical grid connection for granted. Sometimes companies might need to apply for a bigger connection, especially if they are installing lots of new equipment, and this is a fairly straightforward process. But when it comes to installing renewables on your premises, things can get a little more complicated. Let's start off by taking a look at the grid. In the UK, power has traditionally been generated centrally at a small number of very large power stations. Power is then transmitted across the country at very high voltages, using overhead cables or sometimes buried cables. This is called the transmission network. In our towns and cities, there are electricity substations, which are called primary substations. These distribute the power at high voltage to secondary substations, which then transform the voltage down even further to our homes, businesses and factories. Some of these cables are overhead with pylons or wooden poles holding them up, and some are buried. Finally, there are the cables that connect to our homes and businesses at more familiar lower voltage levels. All of this infrastructure makes up the distribution network. The distribution network is managed by the Distribution Network Operators, or DNOs. In the UK, there are 14 DNOs, and they all follow a common framework of rules for how they operate their systems. As I previously mentioned, the whole system was designed to transmit power between large centralised power stations and end users in one direction only. Now that we have a lot of decentralised energy sources, such as solar PV on buildings, power can flow in directions that the system wasn't originally designed to be for, and this can cause problems for the DNO. Consequently, there are rules and processes that have to be followed if you want to install something that can generate power on your building. Before we carry on, let's introduce some of the technical jargon used when talking about grid connections. The first of these is the fault level. Power network engineers use this term to describe the strength of a section of the network. Imagine an excavator goes through a buried cable in the street and causes a short circuit. The amount of current that could flow during this fault condition is called the fault level. If you add some extra generation capacity to the network, the fault level is going to increase. So the DNO has to ensure that their protection equipment can handle the extra power. Rural areas tend to have low fault levels because the electrical infrastructure was not designed to carry large loads, and physically it's smaller. Adding just a small amount of local generation can increase the fault level beyond safe limits, so it can sometimes be necessary for parts of the network to be upgraded before your renewable energy project can go ahead. Voltage rise. When you connect a new piece of equipment that can generate power to the network, it can cause the local voltage level to rise. If this starts to go outside statutory limits, equipment in the substation will automatically cut off the power, causing a local blackout. Voltage control. Power engineers often talk about taps, and sometimes they give the reason for your renewable energy project not going ahead as out of taps. They are talking about connections on the transformers which step the voltage down between the transmission network and the distribution network. Engineers can physically adjust the voltage level if it's too high or low by moving connections between different tapping or taps on the transformer secondary. Some primary substations have automatic tap changers installed, which perform this function autonomously. Reverse power flow. Because the system was originally designed for power flow in one direction, substations equipment such as online tap changers can malfunction if power starts to flow in the opposite direction. This can lead to problems like voltage rise and blackouts. Power quality. Poor quality inverters can cause issues such as harmonics, high neutral currents, or other problems on the local network, so the DNOs need to ensure that anything connected meets certain standards. As you can see, there are numerous technical issues faced by the DNOs. If you're planning just a small renewable energy installation, your installer can go ahead and get the system up and running without needing to get their approval. But the equipment has to be type approved, and the installer has to notify the DNO within 30 days of installation. A small installation is one which can generate no more than 16 amps per phase. So if you've got a 3-phase power supply and you want solar panels on your building, you'll be limited to around 11 kilowatts of generation, or to put that in other terms, about 36 solar panels.